Yo, hey guys, welcome back to the channel. My name is Dungan, and make sure you follow me on Instagram at Dungan. Today I'm going to be reacting to how I would learn to code. The full video is in the description below. Please check it out. Okay, let's get started.
Just a laptop, internet, and lines of code, you can create something true. Learning to code is one of the best things you can do. If I could go back, with just a laptop, internet, and lines of code, you can create something truly 0 to 1. Learning to code is one of the best things you can do. If I could go back in time, this is exactly how I would do it. I'll break up this video into 3 big chunks: the mindset, coding, and the developer environment. Everything I'm going to tell you is parallelizable, which means there's no real order. And if you're not in college or a boot camp, great. This video is tailored for you. It's definitely harder, but if you're willing to put in the work...
Okay, let me stop there. Well, I'm a computer science student, so I don't know if it's good case today if you're in college or something, it's something like that, but I don't know. But here's why coding this is the right time for you to start learning to code and stuff, because imagine AI is already so advanced and robotics is already coming along, so in 100 years not many people aren't going to have a job or something like that, right? Because it's going to be taken over by robots, whereas developers will always be there since they're the one who's going to be maintaining the robots and the AI systems. So let's continue with the video.
You can definitely learn how to code by yourself. In fact, if I could go back, I don't know if I would have gone to college. Let's get into it. Part 1, your mindset. Coders think differently. We approach our lives and problems in a certain way, and I can confidently say my day-to-day life is different now that I'm a software engineer. Step 1.1, adopt a coding mindset. And what I mean by that is for every problem, inefficiency, annoyance in your life, you need to think there's a solution for this. I just need to find it. It might take me minutes, hours, or even days, but if I look hard enough, if I try hard enough, I will find it. And that means Google is your best friend. Your toaster is broken? Alright, pull up YouTube and start searching. The internet modem is blinking yellow? Google the serial number and start investigating. There's a spider in your house and you want to get rid of it? Yeah, I don't know if Google can help you there. You might just have to move houses. And what I'm saying might sound obvious, but it took me years to realize not everyone is like this. If you were ever wondering why your parents think you're IT support, well, here's your answer. Your parents can Google just as well as you can, but they don't believe they can. And to be a coder, you need to believe you can, as a fundamental truth. Because when it's 4 a.m. and you're working on a programming assignment and you've tried everything, but you still can't figure out the bug, the only thing that'll keep you going is knowing there's a solution. You just need to find it. And that brings me to the second part of the coding mindset: humility. Trust me, when I was in college at TA sessions, I'd be yelling at the top of my lungs, "There's something wrong with my laptop, the code is right, I don't know what's going on, I don't write buggy code." The computer is never wrong. And the second I realized that and truly internalized it was the day I started growing in my coding journey. Step 1.2, learn how to problem solve. Have you ever wondered how airlines decide which airports to fly from, and how shipping providers decide what packages make it on the plane, or how classes are scheduled even though there are only so many on the Well, these are problems solved by algorithms that used to be done by hand. I mean, some pretty legendary woman got us to the moon with only chalk and blackboards. But today, the scale is just too massive. It would take lifetimes to solve these problems by hand. So, we code. At the end of the day, coding is just a tool for...
That's true. So coding is a tool to solve problems. It's like a way of solving, or to write algorithms that solve problem in the software side, something like that.
Solving. The hard part is the actual problem solving. Being a good coder means being good at learning, picking up new things.
Or building logics. That's the main issue, isn't it? It's bringing all the complexity, bringing it to order of n rather than squared or log n. It's all about the logic that you write. That's what differentiates you with other coders or with an amateur.
Technologies quickly, understanding that there's a lot out there that you don't know, but you can learn it all with some time and patience.
Well, here's an example, multiplication. How does basic multiplication work? It's when you just rehearsively add or sum the number, right? So 2 times 3 is basically 2 plus 2 plus 2, which is 6. It's same as 2 times 3. So it just adds together, which is n squared. So the complexity of that is n squared. So that's why it's not efficient. Whereas the optimum one is n to the power 2.7 or something like that. No, n to the power n, right? It's not n squared, isn't it? It's n to the power n. So the most efficient way that someone created was 2 to the n to the power 2.7, I believe. I'm not sure, but yeah, it's just all about the logic that you come up with. That's what differentiates you with the an excellent coder to a normal amateur coder.
At every one of my internships and jobs, I had no experience with the languages they used. C# at Schlumberger and Microsoft, Ruby on Rails at Gusto, and Golang at Bolt. But I learned them all. And at hackathons, my teammates would want to use buzzwords like machine learning and the cloud, and I'd have no idea what they were saying. But I'd figure it out. And yes, you don't have to be a good computer scientist.
Also with this, like, you don't have to know all the languages. If you just know one language fully, or like if you understand every single thing in one language, you could always just apply that same theory to another language. So for example, in like Java, you could lambda expression, you could still apply Java lambda expression in Python as a functional programming. It's still like same, you just have to research. The concept is still the same. So it's like you just need to know the concept of one programming language fully, then you could code in any other languages. So you don't have to worry about learning all the languages in the world.
Be a good coder, but you do have to be a decent problem solver. And hands down, the best for...
You just have to like maths, basically. If you're like really good at maths, or if you're really like solving puzzles or problem solving, then you would love coding. Because you will still get the same enjoyment of completing or solving the problem as you do with like solving a puzzle and something like that.
Resource to improve your problem-solving skills is CS50, Harvard's introductory computer science course that all incoming freshmen take. You have an Ivy League education, one of the best intro computer science courses out there, at your fingertips, for free. Take advantage of it. CS50 will give you a broad overview of computer science, algorithms, and data structures. Is it necessary to learn how to code? No. Will it help you and accelerate your learning? Definitely. The class is language agnostic. You'll be exposed to C, SQL, Python, JavaScript, HTML, and CSS, all while working on real-world problems in biology, cryptography, finance, forensics, and gaming. What you learn in this course will help you immensely with everything else I'm going to talk about.
Well, just think about this. It's like coding is basically applied mathematics. It's like everything you learned since you were a kid in maths. You're just applying it into coding. And after you apply, you could see it work in real life. Like cryptography, gaming, and all of that. It's like with gaming, it's like vectors if you think about it in maths terms, because you arrange all the players in a 3D vector space, then you just put the coordinates and it just does everything, right?
At Rice, the first computer science class I took freshman year was Comp 140, basically Rice's version of CS50, and it energized me to continue my coding journey. Part 2, learning how to code. Now that you've adopted the right mindset, it's time to learn how to code. I can't say the journey will always be rosy, but I promise it will be fulfilling. Step 2.1, learn one programming language deeply. The language you use to learn programming doesn't have to be the same language you eventually use at work, or even in your personal projects.
And also, at start, you might not understand, but it's just never giving up, just keep on trying. It's always like repetition, isn't it? It's like, when you understand, it's this repetition, and you, sometimes, depending on the people, it could take like 3 programming that you understand the program, how it works and stuff, whereas sometimes it could take like 100 tries. Like object-oriented is different to functional programming, so it just depends on like you never giving up and just like keep on trying to figure it out.
It's good to know one language really well, like your go-to. If you took CS50, you've been exposed to a bunch of languages, but for now, I'd recommend Python. It's the most beginner-friendly language, and for the most part, it reads like English. The data structures are really intuitive, and it's not verbose. It isn't typed, which isn't ideal, but you can always use linters to optionally add typing. And this is probably the language...
Yes, Python is the language I would recommend for like beginners or amateurs. Whereas I started with Java when I was like 12 years old, so Java is like really hard. It's like object-oriented straight off the bat. It's not like Pascal programming. Like Python is like a script and Pascal programming. You can just write it in a single page. Whereas Java is like object-oriented. It doesn't work unless you write in classes and stuff, right? So it's like that. It's difficult to understand at the start. But now there's a program like Python where you can just slowly develop on that and move into Python as well. You could do object-oriented programming. So if you just start with like normal Pascal writing, then work on it, then you could do other stuff as well.
Want to use for coding interviews, so it's good to get comfortable with it now. To actually learn coding in Python, there are so many great resources out there. For now, you're going to want to focus on syntax and data structures, so follow an online course or look up some tutorials on YouTube. Make sure you learn about control flow, so if-else statements, basic logic and or not, loops, for and while loops, and objects, classes, and other object-oriented programming principles. In my opinion, these are the highest yield topics. And for data structure... And
also those are the ones that you're going to use, like in any single program. You're going to use an if statement any time if you're going to make a solution to it, or an algorithm. You're going to use an if statement at least once. if you're going to write an algorithm, right? So loops are always important and all of that. So those are the main stuff you should begin with. Rather than jumping to lambda functions I mentioned at the start, you should learn the basics. That's right.
Don't worry too much about crazy.
But it's like learning in maths, you learn addition and subtraction first, then you move into multiplication, division, all of that, right? So it's same with that, and like you're just applying that concept into like your advanced studies with coding as well.
Red, black trees and whatnot. For now, focus on hash maps and arrays. Once you have a basic command of Python, move on to the next step.
Array is easier than cache map, but yeah, you should. No, I think you should start with arrays and list, then go to cache map and all the maps and stuff, right?
Step 2.2, learn scripting. Sometimes there'll be stuff you're doing that will feel really manual, like data manipulation or renaming files. Or sometimes you just want to write code to produce code. You can write scripts on your terminal through bash scripts, but hopefully by this point you understand some Python, so you can leverage it to automate some of your daily tasks. For example, let's say you want to grab data from a CSV file and generate an insert SQL statement that you can copy paste into your database console. And imagine there are no nice libraries that can help you do this. It would take hours if you wanted to do this by hand. But with a simple Python script, you can generate this entire command, copy paste it into the database console, and you're good to go. You basically wrote Python code to generate an SQL query string. That's awesome. The great thing about scripting is you don't have to spin up a web app or worry about hosting your server. You can just write Python code. And writing more and more Python will make you better at it. Coupled with a coding mindset, you now have a practical tool to solve some of your daily problems.
And after that, you will have a practical mindset as well, because when you go out or when you think, you always think practical, like what's going to happen next, or how to solve this, or how to construct this. And like when you have a problem, or like even when you're playing a card game or something, you could always apply like a for loop or while loop, what will happen, like you would know the end result and all of that. So it's you're always thinking practical.
Step 2.3, create a personal project. The first thing I do is sign up for a hackathon.
Also, when you're doing a personal project, make sure you don't use as much library as possible. Like you don't use more libraries for like searching a list. That you should build it. Like you should write the code yourself to understand how it works, rather than using a library. Like in in Java, you can use a collection library to sort the array or sort a list. You should do that. You should write a function like manually of how it should work. Then afterward, you can use it. But you should always learn, you should always write what you're intending to do when you're starting off, rather than just using library all the time.
In person is best, but virtual is fine too. This is much like signing up for a marathon, so you feel motivated to go out there and train. A hackathon will give you the chance to create a project. You'll learn a lot, you'll work with other people, and it'll give you a taste of what real-life software engineering feels like.
And also with the hackathon, you could also enter into a competition with the team, and you could win prizes as well, right? And it's like known for big companies like Google and Facebook, Amazon. And if you tell them that you entered into a hackathon, and it's really good.
Well, except real-life software engineering projects aren't completed in 48 hours, and you actually have to test your code, and you're not as sleep-deprived. But you get my point. You'll get a chance to create something that you can deliver to customers, in this case, the judges. I've said this many times in other videos. The best way to learn programming is by doing, and ideally you work on something you're passionate about. So pick a topic you're interested in and build something. There are a couple things I think are important here. First, you're going to want to pick a full stack project.
And also, like, even after you start with the code, or if you're stuck with it, there's also like communities, like software engineering communities like GitHub and stuff, where you can post your code, any question that you're struggling with, and other developers or other computer science students will help you with that.
There's a front end, a back end, some API message passing layer, and then a database to actually store the information.
Yeah.
You can do everything in Python if you want through Flask or Django, but I'd actually recommend learning and using JavaScript. JavaScript is probably one of the most popular languages out there today, and it has great support for front end and back end. For the front end, I'd recommend React, and for the back end, some framework around Node. Express is a really popular one. Like Python, JavaScript is not typed, so I'd highly recommend using TypeScript, which is actually what industry uses, so it'd be a good precursor anyway. The awesome thing here is that there's so many stacks you can use. Mern is a really popular one, but there's no wrong answers. Just pick one and dive deep. For the message passing API layer, probably start off with the REST protocol, but if you're feeling extra bold, give GraphQL a try. And for the database, I'd recommend using MongoDB, which is very JavaScripty and JSON-like. Or you
MongoDB or PostgreSQL, which is easy as well, I believe.
Use a classic relational database like Postgres.
For
the backend server and database, feel free to host everything locally. But for bonus points, see if you can set up your infrastructure in AWS, Azure, or some other cloud provider, because that's how they do it.
Or Heroku. Heroku, I think, is free for 500 MB, whereas AWS is only like 250 MB, I believe. But I think Heroku is 500 MB if your project is big.
If you're not feeling particularly inspired,
And Heroku is like you don't have to give your credit card either, or won't get charged like as easily as Amazon, because Amazon has like so many services where like for some reason you would just one day you get charged for something that you haven't used, or like your trial period ended or something, whereas Heroku is not. So it's like it's better when you're a student or amateur, when you're not actually developing a company. Whereas if it's like a scalable company, I would recommend AWS.
here's a project I think gives you the most bang for your buck. Implement a stateful counter, which means the front end will have a number, a plus sign, and a minus sign to increment and decrement the counter, and maybe a reset button to set it back to 0. And stateful means if you close the app and reopen it, the count should continue from where it left off.
Or like that, or the way I would always say is like, anytime you start coding, you should always write like the hello world, as like anyone would do. You always do a hello world. After that, I would just say Fibonacci sequence or any type of sequence. Then you because then you would know how to like structure the mathematical syntax in the programming language, and like the method, or like how to construct it into like a readable state. And you could see, because Fibonacci sequence, or like with that you could know how the mathematics of that, and you see how that translates into code. So that's the easy thing to start as well.
And this will force you to use a database to actually store the information. These are called CRUD apps, for create, read, update, delete. The 4 basic functionalities any feature can have. By implementing this, you'll get experience across the stack and have a real-world project to show for your efforts. Step 2.4, practice for interviews. If you're watching this video, chances are at some point...
Yeah, or like, because like even now I'm still a student, but I still do I think it's HackerRanks, where you do interview questions, and like, there are some difficult questions. Like, if you slowly get used to that, then you could, like, your brain will be more active to like interpret questions, and like, the more you do those type of problems, you could see a massive difference. So like, for example, at the start, I could solve that problem in, like, let's say in like 10 lines of code. Then like 2 years later, I could do that whole thing into like 2 or 3 lines of code, because you learn so much more stuff, and technology is always advancing, right? It's like it's dramatically improving even now. Like, for example, Java, I think now is already like Java 15 is out, but we're still using Java 8 or 9. So as you know, it's like, that's how it works.
You want to get a full-time software engineering job, and that means you're going to have to do coding interviews.
Yeah.
And remember when I said just focus on Python syntax and hash maps and arrays? Well, I wasn't lying. By now you have a good grasp of the fundamentals. You're ready to pick up an interview book and start practicing. The classic book everyone knows is Cracking the Coding Interview, but it's honestly not my favorite. The solutions are in Java, which is completely unnecessary since Java is such a verbose language. I'd actually recommend elements of Python programming, since the solutions will be in Python anyway.
Also, I won't recommend that. I think I would recommend I don't use these books or anything, but I would still recommend something like pseudocode, or the solutions to be in pseudocode, because it's a universal program language, or that's the language that everyone should know, right? So I wouldn't recommend it being one language, since it's only targeting a certain minority or like a certain group of people. So yeah, with pseudocode, I think you get a broad idea, because this tells you the answer specifically, whereas pseudocode is like English. It's like semi-English and semi-coding. So if you read pseudocode and trying to implement what the pseudocode is saying into programming language, then you're also learning as you're reading the text or something, right? That's what I would recommend.
Be familiar with the language. For interviews, you'll need to be familiar with strings, arrays, hash maps, trees, graphs, queues, stacks, tries, and heaps.
And linked lists.
Basic algorithms like breadth first search,
linked lists, graphs, there we go.
depth first search, and some other basic sorts and searches. I know it sounds like a lot, but you can get there with some practice. Chances you'll use any of this at the actual job, close to...
And also, like, all of these like terminologies, you know the concept, or you applied it somehow, but you just don't know the concept of it. It's like binary trees, where you just divide into 2, half, which is like, you know how that's how you sort kind of thing, where you take like a container of certain items and you sort into each section, and like sort into depending on what it's like, if it's ascending or like smallest to biggest, or biggest to smallest. You do that like internally, but now you're just focusing into each stages, like mini stages, which is like algorithms for that, right? Or to create an algorithm.
Chances you see these concepts in interviews? Pretty high. You should also learn recursion and practice it. Don't worry if you struggle. I struggle to this day. To truly prepare for interviews, I'd recommend doing practice problems on LeetCode and using these sites that allow you to mock interview other people.
Recursion is a good thing to know, but it's not efficient, because it's still the order isn't as efficient as that. Because when you're doing recursion, you're still like remembering what you got like in the previous recursions in the memory, so it takes up loads of your memory like cache basically, so it's not memory efficient. But it's still useful for small projects. But when you're talking about like billions of data sets, you shouldn't use recursion. It's just better to do a small for loop because that will be more efficient. But yeah, but it's also good to know recursion because like in an interview, they're not going to give you like 100,000 gigs of data, right? So they're just going to be like a small data. Like Fibonacci sequence is a great example to do it in normal with the for loop and with the recursion as well. So yeah.
Then mock interview you. Part 3, your developer experience. Now this isn't technically coding, but it's almost impossible to code without a solid developer environment.
Yeah.
And remember, there's a stark distinction between writing code just to pass a coding assignment and building something in the real world, in a production environment. So honestly, I think getting comfortable with the tooling you're going to end up using every day is probably the best investment you can make.
Yeah.
Step 3.1, learn the terminal. You're going to code on your laptop. Right now, you probably drag and drop things into Windows and right-click to find what you were trying to do. And don't worry, I was just like you, but those days are gone, or they should be gone if you're trying to seriously code. Just like Command-C is way better than right-clicking and hitting copy, navigating on your laptop through your terminal is way more efficient than using the user interface.
And also you could find, with terminals, you could find hidden files like so easily, whereas with like, I don't know, if it's a UI, you can't find the hidden files or all the files. Like for example, sometimes your laptop says that desktop is taking 50 gigs of like memory or something, and you're only see like 10 files because everything else is like hidden files or like malicious files and you could detect that on terminals. So I would highly recommend that.
You know those hackers you see in movies coding really fast? Well, all that is fake.
That's fake,
but the one thing they got right is that they're using the terminal.
Yeah.
And I promise you, sooner or later, you're gonna have to get comfortable with the terminal. So you might as well start now. Couple things here. If you're on Windows, I'm just gonna say it, the command line is not it. The Linux flavor.
Also, I think maybe like in 2 years with experience, like 2 years with like programming experience, also learn the ARM language as well. That's the basic or like the first programming language. That's where you can like, where you just write in bytecodes, right? So it's like when you could see how like just writing an add in the computer, making sure like 1 + 1 is equal to just the add operation is like, it's like, I think it's like 50 lines of ARM code. So if you learn that, that's also useful. That's like, it's better to understand as well. Like you're never going to use it. It's just like the information. That's like, you could see how it improved from ARM to now Python, Java.
Way nicer. So I'd highly recommend you get the Bash subsystem for Linux. And if you're on Mac, I'd highly recommend using iTerm2. It's way nicer than the default terminal. Now you have a couple options. You can use the default shell, which is usually Bash.
It's on I use a Mac, so I used to do that. But I think on Windows it's like I think it's called PowerShell. So it's like same command as Linux, whereas command prompt is not. It's like its own. Windows commands, whereas PowerShell is like Linux commands. So it's bad to use that.
Use some wrapper like Zish, Oh My Zish, or Fish. No hard opinions here, but just pick one and learn it. And if it makes a difference, I personally use Oh My Zish. Get comfortable with the package manager and commands like sudo, ls, mv, rm, and so on. And the best way to do this is to force yourself to only use the terminal to navigate on your laptop. It's like when right-handed people want to become ambidextrous, they start brushing with their left hand. Let's say you want to move a bunch of files to a new directory and then open that folder in an editor. Cool, you can do it on the terminal. The terminal can be gnarly, and you might have to Google a bunch and resolve all these dependencies, but that's great. More practice. Step 3.2, learn your way around an editor. I'm not a Vim or Emacs power user, and I'm not going to debate you on tabs versus spaces.
I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us.
But trust me, you're going to want to know your way around a coding editor. My go-to in college was Sublime. But honestly, looking back, hands down.
Also, I would highly recommend using or like having one preference was editor or like IDE. I use IntelliJ, which is by JetBrains. So even when I'm using Python and stuff, I don't use the Python standard one. I just still import that into thing. Even Prolog or Haskell, when I use that, I still import. I download the Python or Haskell SDK and just put it into my IntelliJ. And it works, so it's just manipulated. So like when you get one program into one IDE, then you should know how it works and stuff.
Best open source editor out there today is VS Code. So download it and start navigating around.
Watch Studio is free, whereas I think the one I said IntelliJ is still free, but it's only like, I think it limits you for something. But whereas Watch Studio it gives you a lot more
extensions like Prettier and ESLint. And browse through some themes and other settings and really just get comfortable with the whole environment. I'd also recommend any JetBrains IDE, like
There we go,
IntelliJ for
IntelliJ,
Java
there
or
we go.
Golang for Golang.
Yeah. So
You're gonna
here,
have to
I
buy a
think was it.
license,
Let me
but
go
these-
back. So like for Python, it's PyCharm or something like that. I don't use any of that. I just use IntelliJ and just get the SDK for that, then just put it into IntelliJ. That's why you should do that as well, rather than downloading everything, because it's going to take up your computer storage and it's useless because it's just an editor, it's just an IDE, right? You just need the SDK from the program, like you can just download it from the website or like from the actual website, like it's Haskell. Just go to the Haskell website and download the SDK and just import it to your IDE.
Or Golang for Golang. You're gonna have to buy a license, but these editors are powerful and they can level up your coding ability. Step 3.3. Learn Git and become familiar with version.
Like you don't need it, but it's just more efficient. Like it improves your coding speed as well as then also like in a long term you could see the difference. Let's put it that way. Because like you can still write a code in a text file and still run it. Because you just had to get the text file and just run it on terminal. You can still do that, right? It should still work. Like you can write a Python code in a text file, then it's like with a .txt extension and still run it on terminal using a Python 3, then open that as a Python file. It should still work if all of your syntax and all of your spacing is correct. But just with the IDE, it just does all the spacing with the tabs and stuff perfectly, so you don't have to worry about any of the syntax error.
This far, you probably know what Git is.
And also you could debug. So in IntelliJ with the IDE, you could click the debug words. You could iterate like the steps one by one with the text file. You can't do any of that. So you had to run it. So you're the debugger yourself, whereas and you're the compiler yourself as well. So whereas that you are the IDE has an own debugger which does it for you.
While playing around in the terminal, or used it in CS50, or used it during a personal project. Git is just a version control tool that allows you to save checkpoints of your work. You'll definitely use Git or some other source control tool throughout your career. I remember in my first hackathon, we were all coding all night, and then we were finally ready to integrate our work and merge all our changes together, and we screwed up some Git command and lost everything.
Be careful with
I'm
Git.
still not the most proficient with Git, but you really only have to know the basics. Git pull.
With Git, make sure you first try it out before you start with a group. Because with a group, if you accidentally merge, like you could accidentally delete other people's work or just overwrite your work with theirs because your current branch isn't up to date or something. So just before you do, before you work in a team, before all of that, just create your own project, put it into Git, and every time you make an improvement, also update Git as well. It's like having a backup. It's like a backup storage as well, kind of. So just think of it as that.
Merge, rebase, commit, push. That's about it.
Yeah.
Just remember,
those are the
Git
important
commit
commands.
often, and you'll thank me later.
Yeah.
And while you're at it, check out GitHub, either for your own personal project or just to check out
So
an open
it's
source
the one I was
repository. You can see issues, pull requests, and the entire code base, which is pretty cool. And this is just a nice to have, but check out the README because it's usually written in Markdown. Which
GitHub
is
is a
pretty
really
language to
useful
format
tool
plain
for
text.
developers.
Congrats! By this point, you're well on your way to becoming a coder.
Yeah,
You
if
think
you know
about
that,
things the
then
right way, you have the drive and patience to stick with it, and you truly believe in your heart of hearts that you can do it. And you know Python and JavaScript, you have some projects under your belt, and you have a sound understanding of data structures and algorithms. You're ready for interviews and whatever else the world throws at you. I want to wish you good luck with everything that is to come. And just like everything else in life, it's the journey that matters, not the end result.
that's true.
Take a moment to see how far you've come. I'm proud of you. Keep at it. That's all I have for today. Till next time. Cheers.
Good video. That's a good video. Yeah, what I said is right. So it's like if you do everything as this, yeah, that's yeah. Because these are the guides that so many people or so many developers I know now missed out, or like they don't know what. Like for example, I did an intern and there's some people who didn't know what GitHub was, and I was like, but then you like where do you store the like projects like in university? Where did you do when you work in a group project? How did you like collab together? Because you can't just not 7 people working on one machine, right? That's just inefficient. It's like where you split the it's like you should always follow like an agile format. So you allocate tasks for each different people and they work on that task. When they complete it, then you merge everything together. And GitHub is like a best place to merge everything together, right? So yeah, I think that's right. Well, I hope you enjoy. Make sure you subscribe and smash the like button for the YouTube algorithm. And yeah, that's it. Cheers. Bye.